Hi everyone, this is assignment number 3, page 189, 1 through 3 for Math 11, and these solutions are posted on our course page, but I'm going to add a little bit more information from question to question by going through this. Okay, so this is question number 1, verify that Bernard is on the road with equation y equals 1/2 x minus 100. Okay, so Bernard is apparently at 50 minus 75, so it's apparently at this coordinate. If I take these coordinates and plug in the 50 for x, plug in the negative 75 for y, and if I calculate the right-hand side and I find out that I get the same value as whatever y is, in this case is negative 75, then yes, indeed, that means that this point is on this line, and given that Bernard is at this point, that means that Bernard is on this line. So I plug in 50, and I get minus 75 on this side, minus 75 on the left side, so yes, indeed, Bernard is there. Okay, in B, they say find the coordinates of the point of intersection. Okay, so wherever two points, so if you have one line and you have another line, that intersection point there, that is a particular xy value. And that xy value will satisfy this equation, or this line, the same way that this point satisfied this line. And likewise, this point, which is the same, will satisfy this line. So what we need to find out then is where does y equal y? So what I have up here is I have my my two equations that I was given, and I set them equal to one another and solve. So 1/2 x minus 100 is equal to minus x plus 410. Again, because that means that y equals y, and that y coordinate is the same as this y coordinate. Okay, so set them equal to one another. I've done that. And then I'm going to solve for x. So I add x to this side. I add 1x, which means I add 1x, which is 1 plus 1.5, which is 1.5, which is 3 over 2, is equal to 510. Because I added 100 and added 100 here. Now I need to get rid of this fraction 3 over 2. I can do that by dividing by 3 over 2, which is the same as multiplying by 2 over 3. So that gives me 6 over 6, which is just 1x. Whatever I do to one side, I have to do to the other side. So I multiply by 2 over 3, which gives me 1020 divided by 3, which is 340. To find y, I can come back up here and plug x into either one of these equations. Doesn't matter which one. I chose this one because then I avoided the fraction. So I plug in negative 340 plus 410, I get 70, and so the point of intersection is 340 and 70. Okay, so moving on to question number 2. In this case, they find the equation of the perpendicular bisector. Okay, so the first thing I did is just drew this out so that I could see what I'm looking at and get a better idea of what's going on. So here's my point 22, my point 46. They give this to me. I want to know what's the equation of this line. All right, so the first thing I'm going to do is find out the slope of the given line, which is just y2 minus y1, da, 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 da. And again, I just label these x1, y1, x2, y2. I find out the slope of this line is 2. All right, so next, the perpendicular line, this one, will be the negative reciprocal of this slope. So given that this is 2, which you can think of that as 2 over 1, the negative reciprocal is going to be flip this upside down. That's a reciprocal, which is 1/2, and then a negative sign, negative 1/2. Okay, if this was negative, then this would end up be positive. The signs are always opposite. Okay, so negative 1/2. Okay, so now I need the bisector point. I need to know what is that point. Well, that's going to be in the middle. And the midpoint, I've already done this a couple of times, but you can find this on page 150 and on page 185 if you need a review. Here it is as well. This will find you the midpoint, x1 plus x2. So I did that, so there's the midpoint. So now I have the midpoint of this segment, which is also a point that is shared. It's also a point on here. What I need is an equation of the line. The question is asking me for an equation of the line. So an equation of the line, that's y equals mx plus b. That's the slope-intercept form. This is a point-slope form. As long as I have a point and a slope, then I can use this to make an equation. Do I have a point and a slope? I sure do. I already found that out in these steps here. So now what I do is I take my negative 1/2, which is my slope that I found right here. I take a point that I know that's on this line, which is 3 and 4. So this is like x1, y1. And I plug that into here. So y minus y1, that's 4. X minus x1, that's 3. And that's it. Plug that in. I distributed my negative here. Negative 1/2 times x is negative 1/2. Negative 1/2 times negative 3 is positive 3 over 2. I added my 4 onto this side. So, and then what do I do here? I need to add these two fractions. So I need a common denominator. So I multiply by 2 over 2 because whatever I do to the bottom, I have to do to the top. And there we go, negative 1/2 x plus 11 over 2. Okay, so that's 2a. 2b, find the equation. I rewrote this from what's in the book. Find the equation of the perpendicular bisector of CD if the equation of the line passing through C and D is x plus y is equal to 3 and the midpoint of CD is 2, 1. Okay, so again, I wanted to draw a line here to get a better a little diagram to get a better idea of what was going on. So I did that. So here's C and D. And we know the midpoint is 2, 1, so right there. And this is what I'm trying to find, the equation of this line. Okay, so I know I've been told that this is x plus y is equal to 3, which is y is equal to negative x plus 3, another way to state it, and putting this into slope-intercept form. Okay, so now I want to know this line. So again, I go back to the point-slope form, which is this. I need to know a slope and a point. Well, I already know a point because it gave that to me, 2, 1. So there's my 2, there's my 1. What I need to figure out then is, well, what is the slope of this perpendicular bisector? Well, it's going to be the negative reciprocal of this one. So this is negative 1. What's the negative reciprocal of 1? Well, 1 over 1 flipped upside down is 1 over 1, and the negative of negative is a positive. So there we go. And remember that two lines that are perpendicular to one another, if you multiply the slopes together, they equal negative 1. So 1 times negative 1 is negative 1. Okay, and then I just solved for y here. This just becomes 1 times x, 1 times negative 2, which is just x minus 2. And then I added 1, negative 2 plus 1. Boom, there we go. Okay. Question number 3. I wrote out a lot on this to try and make things easier. Is this thing 3 pages, 2 pages? And again, by going over it here, hopefully it's straightforward. It's a short question as far as it's just define the distance from a point to a line. But as you can see, there's a lot of work involved. But again, I kind of, I did every single step here, and hopefully that it helps a handful of you. So once again, I drew a diagram so I could make sense of what's going on. I have a road roughly going through these 2 points. I have a hotel up here, 2 to 4. What I'm trying to find out is what is the shortest distance. Now we know, like, that's not going to be the shortest distance. This isn't going to be the shortest distance. It's not going to be some curvy, whole bunch of curves going on here. We know it's going to be a straight line from here to here, and we know it's going to meet at a right angle. In other words, it's going to be perpendicular. So that gives us some hints about what's going on already. All right, they told us that the road is 3x plus 5y plus 8 is equal to 0. So that's the equation of this line. So the way that I found these 2 points is that I found the x and y intercepts. So I know that at the x-intercept, I know that y is equal to 0. Likewise, I know that at the y-intercept, x is going to be equal to 0. So if I start off with an equation with 2 unknowns, but I know one of the unknowns, then I can solve for the other. So that's what I did here. I set x is equal to 0, I solve for y. So I set x equal to 0, there we go, I plugged in and substituted, solve for y, and I get y is equal to negative 8 over 5. So that's this value right here. And a little quick calculation, how did I know that it was on this side of 2 and not here? Well, if I divide 5 into 8, that only goes once, right? It goes once and I got a little bit left over, so there we go. To find my x-intercept, I set y is equal to 0, solve for x. There's my 0. 3x is equal to minus 8, which is minus 8 over 3. And again, how many times does 3 go into 8? Well, it goes in twice, right? Because that's 6. and then a little bit more. So that's what I did up here. It's like twice and a little bit more. Not necessary to be accurate, but it's nice to be on the correct side here. Okay, so those give me those 2 points. All right, and again, the shortest distance, excuse me, and that's what I say through all here. The shortest distance is going to be perpendicular. I know the slope here. Well, what is the slope here? The slope here is, again, this is what I started off with. So I solve for y, move the positive 3x, so subtract 3x, subtract 8. That's what I have here. Divide everything by 5, so that's how I get here. And now I know that my slope of this line is negative 3 over 5, which also makes sense. It's going down as we move from left to right, like going downhill, so that's how I get my negative. Okay, so if I know that this is negative 3 over 5, that means that this perpendicular bisector is the negative reciprocal. So I take my 3/5, flip it upside down. That gives me 5 over 3. Well, actually gives me negative 5 over 3, but then I have to go from a negative to a positive, so I know that this is going to be 5 over 3. Okay, so I want to find the equation of this line, and I now know a slope. I now know a slope of this, and do I know a point? Well, do I know a point along this perpendicular bisector? Well, actually, it's just a perpendicular. It's not bisecting, but it's perpendicular. Yeah. Well, I've been told the hotel is at 2, 4. So now I have a point, 2, 4, and I have a slope 5 over 3. So I can use my point slope form of an equation and figure this out. Point slope form. There we go. Plug in 5 over 3. Plug in the point, 2, 4, solve for y. So first of all, I distributed my 5, so that's 5/3 x. 5/3 times this is negative 10 over 3. Add 4 to this side, add 4 to this side. I have 4 over 1, which I need common denominator with 3. So I multiply the bottom by 3, I multiply the top by 3, and that gives me 12 over 3. So that's here, negative 10 over 3 plus 12 over 3, which is 2 over 3. So now I know that this line here, which I haven't drawn in yet, is y equals 5/3 x plus 2 over 3. But on the next page, I did draw it in. So here we go. This is the equation for this line. This is the equation for this line. Now I need to find the distance from this point to this point. And that is the distance formula, which I already used quite a bit in the last assignment. So again, they're going to meet where y is equal to y because this is a shared point here. So here's my y. So I set these two equations equal to one another, which is 5/3 x plus 2/3 is equal to negative 3/5 x minus 8 over 5. I want to get rid of these fractions here. So I multiply by 15 and 15. Why? Because 3 goes into 15 even number of times. 5 goes into 15 an even number of times. And I found out 15 by multiplying these together, 3 times 5. Okay, so this means 15 times 5x and 15 times 2. Okay, so 3 goes into 15, 5. So 5 times 5 is 25x. And again, this is 15 times 2, which is 30. 30 divided by 3 is 10. But what I really did is went, 3 times 15 is 5. 5 times 2 is 10. Okay. And then over here, I do the same thing. So I get 15 times this. I get negative 45 divided by 5, which is 9. I can do this again. 5 into 15 is 3 times negative 8, negative 24. And then I move everything over to this side. I move my x's, so plus 9 is 34. Subtract 10 is minus 34. Divide, I get negative 1. Now that I know what my x value is negative 1, I can pick either one of these equations, doesn't matter which one, and plug in x is equal to negative 1 to figure out what the y value is. So I just chose this one. Plugged in, blah, 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 and I get y is equal to negative 1, and there we go. And when I draw that line, that's actually pretty close to negative 1, negative 1. But I did the math just to figure it out. Okay, so now we just need to find the distance from here to here, because that's what the question is actually asking for. And now that I know this is -1, -1, find the distance between these 2 points. Distance formula, plug it in, way you go, root 34, 5.83, and that is that. If you have any follow-up questions, please let me know.